Going to revisit this model we're talking about yesterday. Unequal intersecting pitch roof of a 5/12 to a 9/12 gives us bastard hips and valleys. We needed to establish the lengths by way of the miter ruler. But first we want to talk about the span, which is 45 inches minus 1.5 inch ridge divided in half gives us 21 3/4 of an inch of a run. And we don't know the run of the high pitch yet, nor the ridge length, nor the jack rafter runs, so that we can calculate their lengths. Once we establish their runs and we have the secants of these, we can establish their lengths. Now the secant is a squared plus b squared equals c squared. Unit run, unit rise. So 12 squared plus 5 squared, the square root of which is 13, divided by 12 to put it in inches is 1.083 secant. 9/12, unit rise and unit run, so 9 squared plus 12 squared, the square root of which is 15, another whole number, divided by 12 inches to put it in inches gives us 1.25. So we know those, 1.083, 1.25. So as soon as we find these runs, we can calculate their lengths. And then yesterday we went over the method by which you can get your hip or valley lengths or line length ratios, which we really need, which is the secant for it, by creating this miter ruler. It's the average of the two pitches, a 9/12 to a 5/12 to a 9/12. We just drop the 12s and divide the rises. 5 divided by 9 equals 0.555 times the long leg, which is always 12 inches to keep this miter ruler small, gives us 6.66. The diagonal is what they used to call the seat, or the hip travel, not to be mistaken with the run. Run is always a common rafter run. We know that this common rafter is a 5/12 because we're always using the low pitch for the long leg of the miter ruler. That should be burned in. So since we have 12, the rise is 5, we're given 2, we have to find the third, we already did. Now we gave ourselves these 2, and we have to find the third, so then we can establish the 5-inch rise and then find the hypotenuse, right? So we're just going to do this really fast. We're not going to wait around. We said it's 5 divided by 9, right? 0.55 times 12, which is the shallow pitch leg, equals 0.666. And then we got to use a squared plus b squared equals c squared to get the hypotenuse. So 6.66 squared plus 12 squared equals, and then the square root of, always equal, and then the square root of, which is 13.72, which is the length of the seat or the travel. And then we have that, and we have 5. So now we have 2 more, and we have to find the third using squared, 13.72 squared plus 5 squared equals square root of. That's 14.6. That's the length of the hip on our mock-up yesterday, remember? From point to point, the length of it. Common rise, right? But to make it the secant, or the line length ratio, which is the ratio of the common rafter run to the line length, which is the length of the hip going up the rake, we have to put it in inches. So we divide that by 12. And we have 1.217 that we multiply by the common rafter run, remember? It's a ratio of the rafter length, the line length, to the run. And we know the run is 21 3/4. We already established that. So times 21.75 equals 26.48. 26.5 inches. And here's the framing square set up to the hypotenuse, basically, and the rise. You can bring it over here, set it on the wood. Come to find out it's a 20-degree angle. If you use the math, you can use the math instead. If you have a right triangle, you can use the math from center line to center line. Now, always square down from your center line. And if you want to mark it center line, you can. But if you just square down, you'll know this isn't a setback line, so you won't run your saw on it the wrong way or whatever. This is a setback line. Now remember, yesterday we had a 2 1/4 inch setback. We were talking about setbacks for a while. This is the setback, right? How far to measure to draw a plumb line parallel to the center line, plumb line, so that when we run our saw through, we can establish the point, right? And so this one was 2 1/4. The other side, which by the way is always going to be this steep, on one side there'll be the steep cheek cut and the shallow cheek cut. Same with the other side. 26 3/4 is the length of the center line, and then square to it, which is in plan view. All deductions are in plan view on the miter ruler, is 11/16. Set your saw to 29 degrees on this that we got off the miter rule. Run it that way. And the other one is 61 degrees to get this effect, right? So here's the model, in completely assembled, right? You can see the hip is 26.5 inches long. And we established, like we said yesterday, the bevel by going parallel to the seat cut. That's all you have to do. And that'll make it the same all the way around the corner. If you don't back it, it'll change. It's a little bit more complicated if you don't back it in this instance. What we need to know here is the runs of the steep pitch rafters. We know the shallow pitch rafter runs because we were given the span. We don't know the runs of these steep pitch rafters. So this layout is based on this span because the pitch, the split pitch determines the ridge length. And you have a king common on either side divided by 3 gives us 10 3/4 of an inch. So everything is laid out 10 3/4 of an inch. Over here, I measured 10 3/4 of an inch, made a mark here. You can do this on the plan, on your cutting list, or you can do it in real time. We want to know we're measuring in between the lead edges here. Very important, right? Short point to short point. We always cut to short point here in California, but you can do the long point if you're used to using a different type of saw. We always go to short point. This is 10 3/4. This is 19 inches total. So the remainder is the plate line spacing, right? And you'll notice when you look down, it's longer than is the run, unlike a standard roof where they'll be the same. So we divided the sides of the miter ruler by each other. 5 divided by 9 equals 0.55, and 9 divided by 5 equals 1.8. And those two numbers are on our list because they're key components to, that is to say, pieces of information, right? In this case, we have a longer plate line dimension than we have a run, so we use the smaller number. Whatever this distance is multiplied by 0.55 will give us a new run for this common rafter, and then the run times the 9/12 pitch secant line length ratio, which is 1.25, will give you this rafter length, this jack rafter length. Now, while we're here, let's calculate what the length of this ridge is in this common rafter, and that you see that You need one before you can find the other. So we talked about it yesterday. The span is 45 inches minus the ridge thickness divided in half gives us the run. Not to be mistaken with the length of the rafter. It's the run that we want, which is 21 3/4 times the short number of the two, just like this jack, which is 0.55, right? 5 divided by 9 is 0.55. So 21 3/4 times 0.55 gives you 12 and some change, 12 and a 16th pull, which is 12.08. Pull for 16th is 06, but it's 12.08. From here, pull 12.08 to this side, and the same on that side. In between is the ridge length. Why? And the answer is because you can see that the ridge length dies onto the outside of these comma rafter. That's the ridge length. But that's also the run. That's the actual ridge length. That's also the run of the comma rafter because it dies into the edge of the ridge in the same location, right? So 12.06 times 1.25, 15 inches in a little bit. It's 15 inches. What about this one here? You see the lead edge once again creating this little triangle here. Looks about 2 1/4 inches. And then if you look straight down, you'll notice this leg is shorter than the run in plan view, right? See the triangle there? So we have to use the big number, which was the 1.8. Remember? The rises divided by each other. So in this case, instead of 5 divided by 9, it's 9 divided by 5 is 1.8 times what looks to be 2 1/4 or something. Will give you the run of this. And then you multiply the run by the secant of the low pitch, which is 1.083. That'll give you the length of the rafter. Mustn't forget to use your template, your 22.5 degree angle template, or 22.6 degree angle template for the 512, which is different than the 912, which is 37, to get your plumb cuts here. And the short point, because we measured to the short point, you could also use the long point and get this side if you wanted to. We always cut to the short point out here of a 61 degree angle that you can use a swing table for. But if you don't have one, you can cut square and plumb, and then just have a stack of blocks that are the on-center spacing, 20 or 10 3/4 of an inch, with a square cut, but a side cut of the low pitch, which is this pitch here, 29 degrees, but square, and it'll go from this face to this corner here, and this will butt against it, and it's actually really nice looking. It looks kind of cool on your roof, right? And it's fast, you can do it, you can get a perfect layout and so forth. Here we are again, lead edge, remember, really important. Measure the spacing, and you'll notice when you look down, in this case, it's the opposite of this one, right? This one's longer than this one, so you have to use the smaller number. So you take this spacing, whatever it is, looks to be like 8 inches or something, times 0.55 will give you the run of this one, but this is a steep pitch. So times the 1.25, the 912 pitch, will give you the length of this rafter. The cheek cut is the shallow cheek cut, 29 degrees, and then the plumb cuts we said already are 37 degrees for the 912, right? Yep, and that's what's happening. Now take a look at this. What if you had, and so if you want to find the length of this ridge, you see it goes from this plate to that ridge. So you could just measure from this plate to that ridge, gives you the length of this ridge here. And you can establish it level and put a post and then start stacking up here. Now, if you wanted to cut this jack rafter, it has a tiny little seat cut. You want to calculate it to the center line and then subtract half the thickness of this valley at the angle that it is, which you can just measure because you have a block of wood with all this business on it, right? Make it a common rafter with the seat cut and the heel stand. In this case, it's 2.5 inches, right, for the 912. It's 2.5 for the 512 too, but 2.5 inches is the seat cut. But whatever, you'd have your 2.5, and then you'd do your subtraction to the long point of the shallow. It's better than trying to get this tiny little seat cut later. Just cut it full length, and then do a deduction and mark it and cut it. That is to say, mark it full length, establish the heel stand, and then draw a secondary mark to the long point, and done. Sometimes you cut to the long point. This is a good example of it. What would happen if you had a 912 main span and a 512 gable? This ridge would be way up here. Common rafters would be these side common rafters would be way over here. But also because this ridge was way up here and this was the shallow pitch, these common rafters would have to go a really long time before they got to the same elevation as the steep pitch, right? So that means the valley would be going at a different angle, be going at this angle here. Well, but you'll notice it's still a 9 to a 5 or a 5 to a 9, right? So it's not unlike this situation here where you have a steep pitch and a shallow pitch. It's 29 degrees, that's 61 degrees. Together they equal 90 degrees, right? 90 minus 29, 61. Same thing here. How do you get the length of it though? You can see this is about 1 1/4 times the run, 1.217 times the run. You can just tell by looking at it. But when you see the other one, if you multiplied it by 1.27, it'd be way too short. It'd be the length. It would be this length. It'd be way too short. So what do? Same thing. Ratio. The longer one, 1.8 times this secant. So 1.217, which is the secant of this hip, times the 1.8 will give you the long valley length if the pitches are reversed, and the seat cuts would switch. The cheek cuts would switch. The 61 would be on this side and the 29 would be on the other. They'd be like that. But other than that, they're the same. So we're just using the miter ruler to establish all of this stuff. Really important. We also use it to figure out different overhangs and offsets and so forth. What happens if you have this roof with another pitch, right? I've done a job where we had 28 different pitches on these 3 different buildings, which means different variations. A 9, a 5 to a 9, a 7 to a 12. These guys went crazy. It was great for us, but it was a strange scenario. You have to be ready. You just create another miter ruler for those 2 pitches and figure out what the ratios are, right? You just can't know too much about what you're doing, which reminds me to prompt you to build models, because this is a really powerful way to increase your knowledge